So we are going to see some basic MCQs regarding cement and properties of cement concrete. So the first question is, what is the primary component of cement? And out of the options sand, gravel, clinker and lime, the correct answer is clinker. Clinker is a nodular material produced by heating a mixture of limestone, clay and other materials, basically making it as the primary component of cement. Next question, what is the role of gypsum that is played by it in cement production? See, the gypsum has its role to enhance, to improve the early strength. Okay, it is added to regulate the setting time of cement and improve its early strength development. Then the temperature range at which clinker is formed in cement production. The range is, the correct answer is 1100 to 1300 degrees Celsius. The explanation being, clinker is formed by heating the raw material to temperature within the range of 1100 to 1300 degrees Celsius in the cement kiln. Question 4. Which raw material provides the main source of calcium in cement production? Out of the options clay, sand, limestone or iron ore, the answer is limestone. It is the essential main source of calcium. Then primary function of the kiln in cement manufacturing. The kiln forms the clinker in the cement manufacturing. Then what is the typical gypsum content in cement? It is given in the range of 5 to 8%. Okay, it helps to control the setting time of cement. Then question 7, which element contributes to the grey color of most cement? The typical significant grey color of cement is given out by iron. Presence of iron contributes the grey color to cement. Then which of the following is not a type of cement? Portland, blended, sulfate or ceramic. Ceramic cement doesn't exist. We have Portland cement, then we have blended cement, then we have sulfate cement, but we don't have any kind of ceramic cement. Then which of the cement is produced by grinding clinker with a small amount of calcium sulfate? The answer is OPC, that is ordinary Portland cement. Then what is the purpose of adding fly ash to cement? The answer is, the correct answer here goes like, it enhances the durability of concrete over time. This is the reason of adding fly ash. Then which compound in cement contributes to the early strength development? The answer is tricalcium silicate, that is C3S. Then which of the following is not a secondary raw material used in cement production? The answer is sand. What is the purpose of adding slag to cement? See, slag is added to reduce the heat generated during hydration process. That's why the correct answer is to reduce the heat of hydration. Then which kind of cement is suitable for use in marine environment? See, the answer is sulfate resistant cement. Okay, wherever chemicals and salineness is exposed to the structure, we are going to use sulfate resistant cement. Then which component of cement is responsible for setting and hardening through a chemical reaction of water? The answer is clinker. Clinker reacts with water to form compound that set and harden the cement. The chemical reaction is initiated from clinker. Now what is the purpose of adding water to cement? Water is added to activate the hydration process, right? Then which compound in cement contributes to the late strength development? See, the late strength development is initiated, or it is the thing which is carried out by dicalcium silicate. Then what is the purpose of curing in cement and concrete application? Why we carry out curing? See, it is done to maintain adequate moisture level for proper hydration and strength development in cement and concrete. So the answer is to ensure hydration and strength gain. Then which type of cement is used for mass concrete construction to reduce heat generation? We are going to use low heat cement for reducing the heat generation whenever we are going for mass concreting, just like dams or some masonry structures are there. Then what is the purpose of adding air entering agents to cement? In order to improve the workability, we are going to add air entering agents. Then which compound in cement contributes to the color and resistance to sulfate attack? Tetracalcium aluminoferrite or C4AF contributes to color and sulfate resistance in cement. Then which type of cement is known for its high early strength development? The answer is rapid hardening cement. Rapid hardening cement is designed to achieve high early strength. Then what is the function of calcium sulfate, or let's say gypsum, in cement production? Gypsum regulates the setting time of cement. Then which type of cement contains a significant amount of pozzolanic material? The answer is Portland pozzolana cement, that is PPC. It contains pozzolanic material which contributes to improved durability of cement. Then which component in cement provides a source of alumina and iron? Tricalcium aluminate provides a source of alumina and iron in cement. Then which type of cement is produced by intergrinding Portland cement clinker with specific amount of calcium sulfate and pozzolanic material? The correct answer here is Portland pozzolanic cement, that is PPC. Which type of cement is commonly used in architectural application due to its white color? The answer obviously it is going to be white cement, right? It gives the aesthetics to the structure. Then what is the main feature of rapid hardening cement? It gains strength early, right? The early strength gain is the essential property that rapid hardening cement has, and it is suitable for project requiring early load bearing capacity. Then which type of cement is suitable for use in construction where the risk of sulfate attack is high? Obviously, when we are saying that the risk of sulfate attack is high, risk of chemical attack is high, risk of salineness attack is high, and we are obviously going with sulfate resistant cement. Then what is the distinctive property of low heat cement? It generates, see the name itself it is suggesting, low heat cement generates less heat during hydration and reduces the risk of cracks in large concrete masses. For example, if we are going for a dam construction or a massive construction or any kind of monolithic construction, then we will be going with low initial heat generation cement, which is the low heat cement. Which type of cement is obtained by grinding granulated blast furnace slag with Portland cement clinker? The answer is composite cement. Okay, composite cement is produced by blending or adding two kinds, that is granulated blast furnace slag and Portland cement with clinker. Then what is the primary advantage of using hydrophobic cement? Okay, the word hydrophobic means having phobia of water. That's why the water which will be keeping away from water, or which is going to be hydrophobic or waterproof, it is the hydrophobic cement, right? It has increased water resistance, and that's why it will be used in water bodied structures. Then which type of cement is suitable for use in high temperature environment such as foundries and furnaces? Then we will be going with high alumina cement because it can withstand high temperatures, very high temperatures. Then what is the purpose of using expansive cement? Then to induce controlled expansion, we are going to use expansive cement. It has application in pre-stress and post-tension concrete application. Which type of cement is designed to set and harden underwater? The answer is underwater cement. Whenever we are going for underwater construction, such as bridge piers are there, or any kind of structure which is submerged in water, then we will be using underwater cement because it hardens effectively and it sets properly underwater. And what are the main characteristics of oil well cement? Compatibility with oil-based drilling fluids is the basic or the very property of what, or characteristic of oil well cement. Then which kind of cement is used for lining furnaces and kilns due to its high refractory properties? The answer is high alumina cement. We already saw it. It can withstand high temperatures, and that's why we are going to use high alumina cement wherever temperatures are very, very high. Then which type of cement is used for application requiring resistance to sulfuric acid attack? See, acid attack, chemical attack, attacks from salinity, attacks from any kind of chemical is there. We use acid resistance cement. Then what is the primary use of masonry cement? See, masonry cement is used for general construction purpose, that is bricklaying or plastering or construction where it is exposed to atmosphere. It is used over there. Which type of cement is used in construction of dams and other massive concrete structures? The answer is composite cement. Okay, because of its heat reducing properties, or we can use low heat cement also here, right? Composite cement has its heat reducing property, and whenever we are going for massive construction such as dams, the heat cracking is a problem. That's why we are going to use either composite cement or low heat cement. Then what is the primary purpose of air entering cement? The sole purpose of air entering cement is to improve workability and durability of the concrete mix. Then which type of cement is used for the repairing damaged concrete structure? Then we will be using repair cement. Okay, by graniting grouting method, we are going to use repair cement for that. Which type of cement is used for decorative purpose and to achieve various colors in concrete? We are going to use colored cement for aesthetics, for decorative purpose, for that specific appearance. Which kind of cement is used for soil stabilization and ground improvement projects? Soil cement is the answer. It improves the mechanical properties of soil and increases the stability of the soil in which the structure is getting constructed. What is the primary purpose of blended cement? In order to reduce environmental impact, we are going to use the blended cement. Then which type of cement is commonly used for making non-structural concrete product like tiles and pipes? Okay, we are going to use masonry cement for that. What is the primary purpose of white Portland cement? The answer is decorative application. Obviously, it provides good aesthetics and appearance. That's why we are going to use the white Portland cement for that. Which type of cement is used for grouting and anchoring applications? The answer obviously from the option looks like to be the grouting cement. Then which type of cement is used to repair concrete structure subjected to chemical attack and erosion? Obviously, whenever we are saying chemical attack, erosion, salinity attack, either the answer should be acid resistant cement, or whenever we are saying that sulfate attack is there, then we will be using sulfate resisting cement. Then which of the cement is used for underwater construction and repair work? The answer is going to be underwater cement. Then what is the water cement ratio in concrete mix design? Okay, it is the ratio of water content to cement content, right? Whenever we are fluctuating the cement water cement ratio, we are going to fluctuate the workability, the strength and durability of the concrete. Then a low water cement ratio typically results into higher cement. Okay, lower water cement ratio lead to improved cement hydration and increased compressive strength. Then excessive water in a concrete mix can lead to reduced durability. Okay, extra water, less the durability. More will be the workability, but obviously durability is going to be less. Addition of excess water may lead to bleeding and segregation also. What is the primary purpose of using chemical admixture in concrete mixture? Enhancing the workability. Okay, the sole purpose of using chemical admixture in concrete mixture is to add on the workability property of concrete. Then the water cement ratio affect which concrete property the most? Then the answer is going to be compressive strength. The water cement ratio fluctuation is going to fluctuate the compressive strength of cement or concrete. Which statement is true regarding the water cement ratio and durability? The answer is lower water cement ratio improves durability. Which factor contributes to increased strength of low water cement ratio of concrete? The answer being improved cement hydration. Okay, a lower water cement ratio promotes better cement hydration leading to higher strength, that is higher compressive strength. What is the recommended water cement ratio range for most structural concrete application? The range is 0.25 to 0.35. Okay, water to cement content should go in the ratio range of 0.25 to 0.35. Then which type of water is typically not suitable for concrete production? Obviously, it is going to be seawater. See, potable water has no problem, deionized water has no problem, distilled water will not be containing anything which will be harmful for concrete. But seawater, it consists high salinity, high contents of chloride ion. They are going to cause corrosion of the steel that we are going to, that is, they are going to corrode the reinforcement. What is the maximum allowable chloride ion content in water used for mixing concrete? It should be less than 200 ppm. Okay, maximum we can have it as 200 ppm. Suggestible is, what is being suggested is it should be less than 200 ppm. That's why the reason of not using seawater or saline water in concrete making. Why is using excessively hard water not recommended for concrete production? See, obviously it can contain chloride content. That's why it is going to affect the workability. It is going to affect cement hydration. It is going to affect strength, and ultimately it is going to affect the reinforcement that we are going to provide in concrete. Then which factor is of utmost, means highest importance when considering the quality of water for concrete mixing? Then is it going to be color? No. Taste? No. Odor? No. It is going to be pH of water. pH of water is going to decide whether it is being acidic or alkaline, and we don't want any of that range. We don't want acidic water or we don't want alkaline water. We want neutral water, right? Then what is the acceptable pH range of water that is being used for concrete mix? It should be the neutral range, that is 5 to 7, or let's say 6.5 to 8.5. Okay, the range should be neutral one. It should not be acidic like here in the option it is 2 to 4, nor it should be alkaline, that is 8 to 10 or 11 to 14. Then why the presence of organic matter such as oil, grease or undesirable concrete in concrete mixing water? Okay, then it is going to reduce the concrete strength and durability, right? Organic matter interfere with cement hydration, leading to reduced strength and durability, and organic matter is putrescible, means it will go away. It is going to create voids in the concrete where we are using that specific cement. Then which type of water source is typically the best choice for concrete production? See, out of these sources, these are natural sources. Which one? River, then well, then rainwater. And out of that, municipal tap water is controlled. Okay, whatever the contents of water are in there, they are controlled. That's why the pH range will be okay, the chemical contents are going to be okay. That's why the treated water, that is municipal tap water, is used for concrete production. We cannot use river or well or rainwater for that. Now, what effect can high sulfate content in the water have on concrete durability? High sulfate content is going to have that increase in sulfate attack risk. Okay, then concrete structure and durability is affected because of sulfate content. That's why we are going to see that sulfate content being high in water going to increase in sulfate attack risk. Which water quality parameter affect the workability of concrete and setting time? Alkalinity affects the setting time and workability of concrete. And what is the primary concern when using water from unknown source for concrete mixing? It doesn't have anything to do with aesthetic property, that is what is the color of water, or what is the temperature of water, what is the taste of water. Ultimately, the chemical impurities that are present in water are going to affect the concrete mix. That's why the correct answer is chemical impurities in water is the primary concern. Okay. Which water source should be avoided due to the risk of containing harmful substances that affect concrete performance? Okay, industrial wastewater. We can go with potable water, obviously. Municipal tap water is the perfect one. Then well water, if it is being used for a drinking purpose, then we can use it for concrete mixing also. Rainwater, if it is not being contaminated, then it's okay. We can once use rainwater, but industrial wastewater has highest content of chemical contents. That's why we are not going to risk our concrete with industrial wastewater. Then how can water cement ratio and water quality contribute to concrete sustainability? The answer is by improving long-term performance and minimizing maintenance. The water cement ratio and water quality contributes to concrete sustainability. Then how does water cement ratio influence the potential for efflorescence in concrete? Lower water cement ratio reduces efflorescence. Okay, efflorescence means giving out some chemicals, giving out some gases, or giving out some compound. Okay, lower the water cement ratio is, then migration of soluble salt to surface is decreased. Okay, when we say efflorescence is there, like we have seen in bricks, efflorescence causes the minerals, the salt, to come out to the outer surface. If the water content is high, then the chances of salt coming to the surface is high. But if the water content is low, lower water cement ratio have this tendency to reduce the migration of salts or minerals to the surface. Then why it is important to ensure uniform water distribution in the concrete mixture? To maintain consistent properties. Okay, homogeneity is important, right? That's why uniform water distribution is important. Then what is the role of water in hydration process? Then water activates the cement particle. The activity, that is chemical action, is initiated by the water. That's why it is important for hydration of cement. What effect can elevated water temperature have on the setting time of concrete? It accelerates the setting time. Okay, water temperature, if it is high, then it can accelerate setting time. How can the temperature of water used for mixing affect the overall concrete performance? See, it can influence setting time, then workability and strength. Okay, if the temperature is high or the temperature is low, it is going to affect these many performances. What is water admixtures in the context of cement and concrete? See, admixtures are the chemicals or material that we add to concrete to enhance the properties, such as workability is there, or early strength gain is there, or delayed setting time is there. That are the roles played by admixtures. Then which type of admixture is commonly used to reduce the water requirements in a concrete mix without affecting workability? Means we don't have to affect workability and we want to reduce the water requirement. Then water reducing admixture or chemicals are used here. Then what is the purpose of using air entering admixture in concrete? See, workability is increased by introducing air bubbles. That's why air entering admixture are used to improve the workability. Then which admixture is used to extend the setting time of concrete, especially in hot weather condition? Retarding admixture is used to slow down, to delay the setting time of concrete. Then what is the primary purpose of using accelerating admixture in concrete? See, to enhance the early strength development, we are going to use accelerating admixtures. Then which type of admixture is used to improve the durability of concrete in aggressive environments such as marine structure? See, corrosion inhibiting admixture. The sea water or marine water has this content which is salt, that is salinity, means chloride ions will be there. That's why chloride ion causing corrosion to our steel or reinforcement is something that we don't want. That's why corrosion inhibiting admixture should be used in structures, in concrete, which is used for structure that are built in marine environments. Then what is the primary function of shrinkage reducing admixture in concrete? The answer is it reduces drying shrinkage. Okay, the function of shrinkage reducing admixture in concrete is to reduce drying shrinkage. Which type of admixture is used to improve the freeze-thaw resistance of concrete? Okay, air entering admixtures. Okay, it introduces or it creates microscopic air bubble that enhance the freeze-thaw durability. Means in cold countries, in cold climates, we are going to introduce the air entering admixture in the concrete mix. Then what is the purpose of using superplasticizer in concrete? See, to enhance workability without increasing water content, means without changing the water content, we are going to improve the workability of property, right? Then which admixture is commonly used to reduce the heat of hydration in mass concrete placement? Low heat admixture. Either you can use low heat cement, or if the cement or concrete is normal, then you can use the admixture that is low heat admixture. Then how does a plasticizing admixture improve concrete workability? It reduces the water content, right? Plasticizing admixture improve workability by allowing a lower water content while maintaining the workability. Workability is not at all affected. What is the function of a bonding admixture in concrete? See, bonding admixture promotes adhesion between old and new concrete surfaces, right? What is the purpose of using coloring admixture in concrete? To provide a decorative color. Okay, you can use colored cement for that, or you can use a coloring admixture, pigmenting admixture in concrete. And the admixture that is used to reduce the risk of alkali silica reaction in concrete. And obviously, out of the option, you can select alkali silica reaction inhibitor. Then what is the primary purpose of using viscosity modifying admixture in concrete? See, the primary purpose is to modify the rheological properties or rheological behavior of concrete. And which admixture is used to improve the pumpability of concrete? Means in order to pump concrete from point A to point B, then we will be using flow enhancing admixture. Okay, means workability is increased without causing any problem of segregation or bleeding. How does self-retarding admixture influence the setting time of concrete? They extend the setting time of concrete. Okay, they delay the setting time in a specific condition. Which admixture can improve the workability of concrete mixture containing low quality aggregate? Super plasticizer enhance the workability even when the aggregate is not of desired quality. Then how can chloride based admixture contribute to concrete durability? See, they enhance the water resistance. Chloride based admixture can improve the water resistance and reduce permeability. Thereby we can use them in marine structure or challenging environment. And since the permeability is reduced, the chances of chloride ion getting inside the concrete structure and corroding the steel or reinforcement get reduced. Then which type of admixture is used to reduce the segregation and bleeding of concrete mixture? Segregation means setting down of content of concrete, that is aggregates are there, fine and coarse aggregates are there, and the layering of concrete is there. And in bleeding, the water comes out to the surface. These problems are called as segregation and bleeding respectively. Then flow enhancing admixture improve the cohesion and flow of concrete, reducing segregation and bleeding problems. What is the function of grouting admixtures in concrete? To improve the flow of grout material. See, grouting admixture improve the flow and penetration of grout material into voids and cracks. Okay, fluidity should be there. Then permeating or penetrating properties should be there. That is the function of a grouting admixture. Then which admixture is used to improve the water repellency of a concrete surface? Means waterproofing kind of property. Hydrophobic admixture. Either you can use hydrophobic cement by default, or you are going to add hydrophobic admixture in the concrete, so it will be behaving as a water repellent concrete. And how do high range water reducing admixture differ from regular water reducing admixture? See, they provide greater water reduction with less impact on workability. Then which type of admixture is used to improve the compatibility between concrete and mineral aggregates? The answer is adhesion promoting admixture. Okay, it enhances the bond between aggregate and cement paste. Last question. What is the primary purpose of using expansion admixture in concrete mixture? It induces controlled expansion. Okay, expansion admixture causes controlled expansion in concrete, which is useful for pre-stressing and post-tensioning applications. So that's it for today's video. We will see next 100 quick revision of MCQs in the next video. Till then, take care. Bye bye. Welcome to Simplified Learning, and in this video we are going to see MCQs 101 to 205 for cement and concrete properties as continued from previous video. Specifically, we will be talking about workability, various types of cement, white cement, OPC, blast furnace cement, higher resistance cement, air internering, and several other kinds of cement. So let's go to MCQs itself. Let's go to MCQ number 1. What is the definition of workability in context of concrete? See, the definition of workability is that the ease with which concrete can be mixed, placed and compacted without any excess segregation or any problem is called as workability. Therefore, the answer goes as concrete's capacity to be mixed easily and placed without segregation. Out of this four options, the most appropriate one is option C. Then question 102. What are the various three main aspects of workability? Let's see option A. Compressibility, strength and durability, no. Plasticity, porosity and density, no. It is not. Mixing, curing and finishing, it is option D. Mixing, placing and compacting. The ease with which the concrete mix can be mixed or placed and placed and compacted. Okay, then let's go to C. Answer is D. Let's go to question next. What is the significance of achieving good workability in concrete? See, having good workable concrete improves the durability and quality of concrete. Means whatever the structure that we are constructing with a well workable concrete, the durability of the structure increases. The quality of concrete, obviously the quality of structure will be good. That's why the answer is C. Cost of construction is not an aspect. Permeability is not an aspect. Decreases the setting time is not something that has to do something with workability, right? Then question 104, which factor has the most significant influence in the workability of concrete? The answer is water cement ratio. Okay, the fluidity of the mix will be mainly governed by water cement ratio. To some extent, aggregate size, yes, it does matter. Cement type, slightly it matters. Temperature, not, let's not say not at all, but to some extent it will be there. But the most appropriate answer here is the water cement ratio. What kind of water cement ratio you are having, it will be governing what will be the workability of concrete. So the correct answer is option B. Then how does an increase in aggregate size affect the workability of concrete? See, aggregate size, finer it is, more workable is going to be the concrete. Then coarser it is going to be, then it is going to reduce the workability or fluidity of the concrete mix. Thereby the correct answer is reduces the workability. More large size aggregate or coarse size aggregate, excess of coarse size aggregate, if it is in there in concrete, then it is going to affect workability in negative way. Means it is going to reduce the workability, right? Then the effect of using a high water cement ratio on workability. Obviously, more water cement ratio, then it is going to increase the flow property. That is, it is going to increase the workability, right? Then how does the use of super plasticizer impact the workability of concrete? See, super plasticizer increase the workability, right? It add on the workability aspect of concrete. Then what is the influence of higher temperature on workability of concrete? Okay, higher temperature reduce workability. See, high temperature can accelerate setting time and thereby reduce the workability due to faster evaporation. Means water will be leaving the concrete mix and thereby making the concrete less workable, right? Then the primary impact of excessive compaction on workability. Higher compaction is going to lead to segregation. Segregation means setting of coarse aggregate to the bottom and leaving the concrete paste onto the top, cement paste onto the top. It is called as segregation. More or excess compaction is going to lead to segregation and thereby the homogeneous mix of concrete is going to lose its workability. Then how does the addition of entrained air affect the workability of concrete? See, the entrainment or air entrainment is going to reduce the workability, but it has another importance that enhances the freeze thaw resistance, specifically useful in colder countries, right? Thereby the answer is it reduces workability. Then which factor has the minimal effect on concrete workability? It is going to be cement content, right? Aggregate shape, to some extent it has. Admixture type, mostly it can affect. Temperature, yes, but cement content to some extent they are the same. Okay, whatever the cement types are there, then workability is not going to get affected by what cement content is there. Okay, more or less the cement content is going to be the same with some slight difference. And what is the recommended range for good workability as per IS? IS 456-2000 says that 10 to 25% is the range of good workability. Then how does the decrease in workability affect the ease of concrete placement? See, decrease in workability is going to result in mixing difficulties, then placing difficulties, as well as compacting difficulty. Thereby it is going to make placement more difficult. Means whatever place or whatever cast or whatever mold you are going to put concrete, the decrease in workability is going to make that placement process more difficult, right? Then how can a lack of proper workability impact the durability of concrete structure? See, it is going to reduce durability. Okay, less workable concrete, if it is being placed somewhere, then it is going to cause reduction in durability. Okay, improvement not a sin, no effect, not at all. Then accelerate setting time, it has nothing to do with lack of proper workability, right? And what is the primary effect of using excess water to achieve high workability in concrete? See, increasing water quantity is going to improve workability. It is okay, it is going to make highly workable concrete, but the problem is it is going to increase permeability, right? Water will be leaving the pores of the concrete mix, then it is going to leave some spaces, it is going to leave some void. That's why permeability of the concrete is going to increase. Then the role of cohesion in concrete workability. See, cohesion is the property by which the particle, the matter, is going to adhere with each other, bond with each other. Okay, cohesion is going to increase the ease of compaction and placement, right? Role of cohesion in concrete workability is it is going to enhance the ease of compaction and placement. Okay, which type of concrete mix require higher workability for proper placement? See, it is the lightweight concrete. Lightweight concrete requires higher workability for proper placement because it has low density. Okay, then effect of using well graded aggregate. See, aggregate grading, if it is proper, then it is obviously going to increase the workability, thereby it improves the workability, right? Reduction, no. No effect, no. Then setting time, it has nothing to do with well graded aggregate, right? Then primary impact of using larger percentage of fine aggregate on workability. See, it is going to increase the workability, it is going to improve the workability. Okay, finer the aggregate size is there, then fluidity, the flowability of the concrete is going to increase, thereby it will be having great workability. Okay, and how can workability influence the required compaction effort during construction? See, higher workability means more compaction effort is going to take place there. Okay, more compactive effort is required over there, right? That's why the answer is C. Higher workability requires more compaction effort. Then how does the workability affect the potential for segregation in concrete? See, higher workability means more fluidic concrete, more flowable concrete, and thereby high water content ratio is going to be there, which is going to lead permeability problem. Then segregation risk also increases, because when we are saying that workability should be higher, then we are maintaining high water cement ratio, then it is going to cause the problems like setting of coarse aggregate to the bottom, which is segregation. Thereby higher workability increases the chances of segregation, thereby increases the segregation risk. Option C is the right one. Then what is the primary impact of poor workability on the finish of concrete surface? It is going to create a harsh surface, right? It reduces the surface quality and appearance. Option D is right. How does the use of well-graded aggregate impact the workability of concrete? Obviously, it is going to increase the workability. Then decrease in water content in workability of concrete. Decrease in water cement content or water content, okay, or water cement ratio decreases. It is going to reduce the workability. More water content, more water cement ratio, higher water cement ratio is equal to increase in workability, right? And when we are decreasing the water content, workability is going to get reduced. Thereby correct answer is option B. It reduces workability. Then how does the presence of entrapped air affect on the workability of concrete? See, it reduces the workability. We have already seen this one. Then let's see some questions regarding OPC, that is ordinary Portland cement. What is the primary characteristics of OPC? The answer is versatility in construction applications, right? Then which factor distinguish different grades of OPC such as 33 grade and 53 grade? See, the grade that is 33, 43 and 53, it is nothing but the compressive strength of concrete. Then in which job construction is ordinary Portland cement, and OPC is commonly used. See, general construction project means general applications of projects are there, then we are going to use OPC over there. Then what is the typical color of ordinary Portland cement? Means the regular cement that we are talking about. OPC is grey in color, not white, not red, not black. Then which type of cement is often used as the base for producing blended cement with additive? Okay, the answer is Portland pozzolana cement. Okay, OPC is commonly used as the base for producing blended cement such as Portland pozzolana cement. Then what is the main ingredient added to OPC to produce PPC, that is Portland pozzolana? See, what we are going to do, fly ash plus OPC is going to give us what? PPC. Always remember this, OPC plus fly ash is equal to PPC, that is Portland pozzolana cement. How does PPC contribute to sustainability in construction? See, it is using what? Industrial byproduct, which is that, what product is that? Fly ash. Okay, it utilizes industrial byproduct. That's why sustainability, environmental sustainability, we are going to say it is being preserved by PPC, right? Then what is the advantage? What advantage does PPC offer in terms of heat of hydration? It has lower heat of hydration. Okay, compared to OPC, it has lower heat of hydration. That's why the problem regarding thermal cracking of concrete is reduced. Then which application is particularly suitable for PPC? Marine structure. Okay, marine structure is best scenario for the use of PPC. Then what property of PPC makes it suitable for projects with extended construction schedules? Okay, the long-term durability offered by PPC makes it suitable for project with what? Extended construction schedules. Then what is the primary supplementary material used to produce Portland slag cement? Okay, the blast furnace slag is mixed so that we can have what? Portland slag cement. Now, how does Portland slag cement, that is PSC, contribute to reducing carbon footprint of concrete production? Since it is using what? A industrial byproduct, which is blast furnace slag. Just like OPC mixed with fly ash was going to create PPCs, in the same way Portland slag cement is going to use the industrial byproduct, which is blast furnace slag. That's why it is going to leave a proper carbon footprint. Okay, answer is B. It decreases the carbon emissions. Which property of PSC makes it suitable for reducing the heat of hydration? Obviously the answer is low heat of hydration. Large concrete structure means the structure such as dams where massive concrete is done and where we seek concrete with low heat of hydration. That's why we are going to use what? Portland slag cement, PSC. In which type of structure is Portland slag cement commonly used? It is bridge pier. Okay. How does the use of blast furnace slag in Portland slag cement contribute to its improved property? See, addition of slag improves the durability and resistance to sulfate attack. That's why we are using it in bridge pier, where the pier may be in direct contact with water. Then what is the primary characteristic of rapid hardening cement? Okay, the name itself is suggesting something. Rapid hardening cement means it is going to set rapidly, easily, and high early strength development. Answer is B. Then how does rapid hardening cement, let's call it RHC, contribute to efficient construction practices? It allows for fast formwork removal. Okay, because it is setting early, it is gaining strength early. That's why we can remove the formwork easily and early. Then which application benefits most from the use of RHC? That it can be used in precast concrete elements. See, early strength development and quick formwork removal enables it to be used in precast concrete elements, right? And how does RHC affect the overall durability of concrete structure? It is going to obviously improve the durability. Okay. Then what is the key factor to consider when using RHC for construction project? If lower water cement ratio is there, then we are going to consider RHC. Using a low water cement ratio help achieve higher early strength with the rapid hardening cement. And what is the primary advantage of using low heat cement in massive concrete structure? See, in massive concrete structure, if we are going to ignore the heat of hydration, then it is going to cause problems such as heat cracks. Okay, the massive cracks can be seen on the concrete structure after it has properly set because of high heat of hydration. In this case, we are going to consider a mix which gives out lower heat of hydration, right? Obviously, low heat cement is going to generate lower heat of hydration. And in which type of construction is low heat cement commonly used? Mass concrete structure. Okay, remember always low heat cement or low heat of hydration wherever it is required. It is a massive concrete structure such as dam. Then how does low heat cement achieve its characteristic property of lower heat of adhesion? By incorporating supplementary material, we are going to have low heat cement. Okay. How does low heat cement affect the early strength development of concrete? Okay, it delays the early strength development. Okay. Then what is the primary challenge associated with using low heat cement in construction? Longer setting time is the problem, but low heat of hydration is the advantage. Thereby, with some advantage, we are going to have some sort of problem, but looking at the bright side of using a specific kind of cement, we are going to ignore the other one. Okay, the answer is longer setting time. What is the primary purpose of using sulfate resistant cement in construction? It can resist sulfate attack. Obviously, sulfate resistance, in the name itself, it is suggesting that it can resist the attack from sulfate ion from soil and water. And which type of environment particularly aggressive and requires the use of sulfate resistant cement? Coastal areas with salt water exposure are the scenarios where we are going to use what? Sulfate resistant cement. Okay. Then how does sulfate resistant cement achieve its resistance to sulfate attack? Then by controlling the proportion of C3A in the clinker, we are going to have this specific property. It controls the sulfate proportion of C3A to enhance the sulfate resistance. Then in which type of structure sulfate resistant cement is commonly used? Dam and marine structure. Okay, wherever sulfate attack is prone, we are going to use this one. Then what is the potential drawback of using sulfate resistant cement for a construction project? The sole reason here is higher cost. Okay, it is costly, that's why it is the only potential drawback. Then what is the primary characteristic of white cement? Okay, color consistency. Okay, white cement is known for its consistent white color, for its use in architectural and decorative application where aesthetic is the prime concern. Now, what is the primary application of white cement in construction? Obviously, aesthetic purposes, which is architectural and decorative finishes. And how does the cost of white cement compare to ordinary Portland cement is? Then white cement is obviously more expensive. As we are moving further from OPC, the cost is obviously going to vary and more possibly in higher range. And primary ingredient that contributes to the white color of iron cement, it is the low iron raw material. Okay, reduction in iron raw material is going to lead the whiteness of that white cement. And which type of structure benefit most from the use of white cement? Heritage and architectural structure. The sole use you will be saying regarding white cement is the aesthetic necessity, where it is required in heritage structure and architectural structure. Then what is the primary advantage of using colored cement? Obviously aesthetic appeal, it is going to be colored cement means a specific color will be there, and mixing it, having the concrete in that colored cement will be giving that specific look. Then how are the color pigments added to the colored cement? During grinding of the clinker, the pigments are added, right? And which factor influences the final color of colored cement concrete? Obviously, the water cement ratio is going to influence the final color of colored cement concrete. Then what is the recommended practice when using colored cement in the project? Using consistent water cement ratio, because it is going to give out the exact color which is required for that specific structure. Okay, using the consistent water cement ratio. And which type of structure often benefits from the use of colored cement? Industrial structure. We are not going to use in industrial heritage structure. We are not going to use it in industrial building or roadway or highway or underground tunnel. The heritage structure where aesthetic appeal is the main concern, we are going to use the colored cement. What is the primary characteristic of hydrophobic cement? Means phobia of what? Water. Water repellency. Okay. Wherever hydroproofing or waterproofing is required, we are going to use hydrophobic cement in the concrete mix. And how is the water repellency achieved in hydrophobic cement? Means how that hydrophobic cement is being hydrophobic. By incorporating the hydrophobic agent in the mix, we are going to achieve the water repellency. Then in which type of construction hydrophobic cement is commonly used? Obviously, it is not going to be mass concrete structure. Here we are going to require low heat one, then not oil well, not high-rise building. In high-rise building, strength will be the concern. In underwater structure, hydrophobia of the concrete mix is the main necessity. That's why in underwater structure, we are going to use hydrophobic cement. Then how does hydrophobic cement affect the workability of concrete? It reduces the workability. Although remember, hydrophobic cement reduces the workability because it has what? Water repellent agent. Hydrophobic agents are present in the hydrophobic cement. What is the potential drawback of using hydrophobic cement? Reduce bond strength. Okay. Hydrophobic cement may have reduced bond strength with certain material due to its water repellent properties. And what are the primary characteristics of expansive cement? Not expansive, expansive cement. Volume expansion after setting. Okay, it is the primary characteristics of expansive cement. It undergoes controlled volume expansion once it sets. Then what is the primary application of this one, expansive cement? Repairing cracks in concrete. Obviously, when this expansive cement will be going inside the crack, then it is going to expand so that it will be filling it out properly. Then how does the expansive cement achieves its volume expansion after setting? By incorporating expansive agent like ettringite. Okay, by adding ettringite, we are going to have that expansion property. The correct answer is option D. What precautions should be taken when using expansive cement in construction? Avoiding the use of curing compound should be the care that we should take while we are using what? Expansive concrete. Cement, not concrete, cement. Now, which type of structure often benefits from the use of expansive cement? Obviously, dams and reservoirs. Okay. In dams and reservoir, whatever the thermal cracks are there, whatever the cracks because of the setting of the structure is there, we are going to fill them up with the expansive cement. Once the expansive cement goes inside that void or crack, it is going to expand properly by filling out the voids. And it is most necessary in structures such as dam and reservoir because we seek this specific thing over there, which is water tightness. Then what is the primary characteristic of high alumina cement? Okay, high alumina content is the primary characteristic out of these options. Then how does high alumina cement achieve its resistance to high temperature and corrosion? By incorporating high alumina content. The high alumina content contributes to high alumina cement's resistance to high temperature as well as corrosion. The answer is option D. And in which type of construction is high alumina cement commonly used? In marine structure, we are going to use the high alumina cement because it offers resistance to sulfate attack as well as corrosion. Then how does high alumina cement affect the early strength development of concrete? It accelerates the early strength development. Then what is the potential drawback of using high alumina cement? Is the high cost budget. What is the primary characteristic of oil well cement? Resistance to oil penetration. We are going to use this specific kind of cement in oil well construction because it has the property of resistance to oil penetration. Then in which type of structure oil well cement is used? This cannot be more obvious. The answer is oil and gas well. Where oil penetration is the possibility, we are going to use oil well cement. Okay, oil well cement means it is going to resist the entry or seepage of oil inside the structure. Thus, it is being called as oil well cement. How does oil well cement achieve its resistance to oil penetration? Okay, by incorporation of hydrophobic agent. Okay, by incorporating liquid phobic agents. What are the primary challenge associated with using oil well cement? Okay, controlling the gas formation is a problem with oil well cement. What is the unique property of oil well cement compared to other cement types? It has shorter setting time. Okay, it sets early. Now, what is the primary application of masonry cement in construction? Architectural finishes is the primary application of masonry cement. Then how does masonry cement differ from other cement type? It is blend of OPC plus additives. Okay, it is nothing but OPC plus some special agents. What is the primary advantage of using masonry cement in mortar? It gives better adhesion to masonry units. Then in which type of construction is masonry cement commonly used? We are going to use obviously in brick and block masonry. Then what is the potential drawback of using masonry cement in structural application? It has reduced bond strength. And what are the primary characteristics of air entering cement? See, air entering cement is used in colder climates. Alright, thereby the answer being entered air bubble for freeze thaw resistance. Okay, freezing and thawing resistance is incorporated by entering air bubbles. And how does air entering cement contribute to improving durability in concrete? See, it provides air void for expansion during freezing, and those same air voids are utilized when the concrete is thawing. Okay, thereby correct answer by providing air voids for expansion during freezing and thawing. In which type of structure is air entering cement is commonly used? The answer is cold climate regions. How does the presence of air bubble affect the compressive strength of cement? Obviously, when we are saying that voids are present in concrete, then it is going to reduce the compressive strength. What are the important consideration when proportioning concrete with air entering cement? We achieve proper air content. Okay, we achieve proper air content. What is the primary characteristic of high early strength cement? Okay, rapid early strength development obviously is going to be the answer. And how does high early strength cement contribute to efficient construction practices? It accelerates the construction time. See, its early strength is being achieved, less time is getting consumed, thereby it will be accelerating. It will be reducing the construction time. It accelerates the construction process. Answer is B. And in which type of structure high early strength cement is commonly used? In high rise building, we are going to use high early strength cement. And how does high early strength cement affect the long-term strength of concrete? It increases the long-term strength. And what is the potential limitation of using high early strength cement? It is available in a limited portion. That's why this is the only potential limitation. Then what is the primary supplementary material for producing blast furnace slag? And answer is going to be blast furnace slag. It is the byproduct of industries, and using this material we are going to enhance the property of cement, as well as it will be reducing carbon emissions. Then how does BFC, that is blast furnace cement, contribute to reducing carbon footprint? Okay, we just discussed it, we just saw this. It decreases the carbon emissions. Okay, because it is reducing, because it is utilizing or reducing a byproduct from an industry. In which type of structure we are going to use blast furnace cement? We are going to use it in bridge piers, because its durability and resistance to water corrosive elements, means what are the corrosive elements that are present in water, we are going to use it in bridge pier. And how does the use of blast furnace slag in blast furnace cement affect the concrete properties? It obviously going to add on to durability, and it is going to help reduce the heat of hydration, right? And what is the potential drawback of using blast furnace cement in construction? Higher cost. Okay, the problem whenever you are doing something to OPC, it is going to increase in the cost, increase in the budget. So these were the remaining 105 questions regarding properties of cement and concrete. I will see you in next one. Till then, take care.